Welcome to 19071's Design Day presentation. The project is titled Information Interchange Between Collaborative Robots and Smart Devices. This project is sponsored by Continental Automotive Systems. The sponsor is Oscar Ramirez, our mentor is Kat Merrill, and our team consists of myself, Maya Meridian, the team lead, Aliash Kashani, the purchasing lead, TK Chen, Leo Liu, and Tian Yang, the electrical and computer engineers, and finally, our information sciences and technology students, George Hughes, Jacob Langseth, and Ryan Skrnalis. Here is an overview of our project in poster format. This shows everything from what the problem the team is working to solve to our project conclusion. Let's jump into the project. Team 19071 is working to reduce cobot downtimes and potential loss of profit when their unmanned collaborative robots, also known as cobots, break down. Our goal is to develop a system that works on iWatches, iPhones, iPads, Android phones, and Vizix glasses. This system will notify users of downtimes while allowing them to see current cobot statuses. This along with stop, and pause the cobot. Just to clarify, a cobot is a collaborative robot that works with Continental Automotive Systems assembly line to build out their smaller pieces. Some important use cases to the project is the system allowing the user to control multiple cobots, the manager being able to check cobot information through our developed database, the system notifying the user of cobot errors. Our functional requirements are to notify the user of downtimes, be compatible on iOS and Android devices, save the units produced by the cobot, and to control the cobot through a remote application. Here are top-level system requirements showing the compatibility of the GUI, all operations such as start, stop, pause, and error notifications. The system needs to show cobot current statuses, connect to Continental Wi-Fi, work with their 500 cobots, and have a mock database for all our information and overall control of the cobots through their IP address. I've used a systems block diagram to better represent our delivery description. The user accesses the application to see all commands. These commands are sent to the cobot to perform. Once performed, the information is sent to the database to be stored. The application notifies the telecommunication application, which acts like a texting service to all Continental employees. This is another method of notification. As you can see on the diagram, there are stars denoting both the order of importance and the order it was completed. Our first iteration, we picked the goals of start, stop, and pause to communicate via the application and to be stored in the database. Then for iteration 2, we further developed our GUI to show all aspects of the system, including a developed account, and began to process communication with multiple cobots. And this is to be successful on all platforms. For our final iteration, we were not able to complete this due to the stay-at-home order, but it was to finalize counting the units produced by the cobot, connecting live status world cobots, developing our user settings further, and finalizing the connection of the telecommunication application. This is our system architecture, showing how the system is built to show the connection between all subsystems. We've used React Native to develop our code for start, stop, and pause functionalities for Android and iOS. The database stores cobot and user information. Again, the red star is showing what we were not able to develop. Are our acceptance test procedures. It's how we prove our system requirements. As you can see, here are our ATPs for our mock database and for making a new user in the system. Here are the ATPs for testing the GUI and Vizix glasses. Finally, here's the ATPs for using the iPhone and Android phone. Here is our systems requirement verification matrix showing all system requirements. If they've passed or failed to date, their planned verification timeline, and along with which ATP corresponds. You can see some are highlighted in gray. That's to show they were put on hold due to the stay-at-home order. On the slide, that is status, the supply function and notification, the error function and removal, along with live status of multiple cobots as a ribbon. Continuing our SVRM, we have some more of the user account settings. Again, a lot of those put on pause. The reset, remove account, creating an admin, working with permission settings, and adding and removing cobots. that aren't already in the database have been put on hold. Here is kind of more of the same thing. We weren't able to lock accounts or work with failed login attempts, which was one of our goals. Here's the rest of our SVRM. Again, we weren't able to work with the telecommunication application and work with kind of some maintenancing on our database, which we were planning. Here is a demo video showing how to operate our system. The team learned quite a few lessons throughout the project. First of all, how to do agile development, including planning, sprint, and iterations, conducting scrum meetings, and tracking project development through our project management software, Jira. The team also experienced a failed delivery at critical design review and was not able to recover, but also prove a great success at iteration status review. Throughout the duration of the project, the team went through 2 different team changes, causing 4 members to join our team after project proposals and even after critical design review. We learned how to adapt with that, and then finally the team learned. Here are our deliveries. We've reached everything and have it on our share drive and also transferred it via PDF or presentation. We were not able to complete the final acceptance report or review, as you all know. Overall, the team is proud of the results that we got from our hard work and determination, and would like to thank our sponsor, Oscar, and our mentors, Kat and Claude, for their support throughout the projects. We would like to thank the judges today for taking time to hear Project 19071's information interchange between collaborative robots and smart devices. So here's one of our GUIs. You enter some personal information, username, email, a security question, and then you'll do your password. If your password doesn't match, our system will notify you because it needs to be a valid account in order to be created. Let's say you forgot your password, you'd enter your email and you enter your security question in order to recover that password. Next, we'll show you how to operate the cobot. If once you log in, again, it verifies that your account is valid. From there, you see our operation screen where you can select the cobot, start, pause, and operate that cobot. He's showing you start, pause, starting again, then stopping.